Hey you guys, what's up? So if you guys wanted to learn on how to derive a trigonometric functions, you've just clicked the right video. Okay, so we are done with the differentiation of the algebraic functions, and we are also done with the logarithmic and exponential functions. So that is why this time we will be focusing on the trigonometric function. And after this video, I will also be uploading the inverse trigonometric function, the hyperbolic function, as well as the inverse hyperbolic functions. Don't miss these videos, so you just have to subscribe and click the notification bell so that you will be updated of our newly uploaded videos. Alright? So if you really want to learn in how to derive a trigonometric function, the first thing that you have to do is to memorize all of these differentiations. Alright, that's the first thing. So you have to memorize that the differentiation of sine x is just a cos x, and the differentiation of cos x is just a negative sine x, and the differentiation of tan x is just a secant x squared, so on and so forth. So you have to memorize all of these formulas. You cannot solve a trigonometric function, the differentiation of the trigonometric functions, without memorizing these. So you have to start with this. And also you have to consider the trigonometric identities as well as the other differentiation rules, such as the logarithmic rules for the exponentials, and for the algebraic rules. You have to consider all of those things when we are solving the differentiation of the trigonometric functions. Alright, so these are some of the trigonometric identities that is actually very important. Alright, so you just have to take a review for this. You can have your index card there, so you would have something to look at. Alright, so these are the trigonometric identities. Alright, so let's start with our first example. So our first example is we have to differentiate y is equals to x squared times the sine x. Alright, so in solving the trigonometric function, you really have to analyze the equations. You have to look at the operations there, what are the variables, and how it is formed. Yeah, so you really have to analyze the equations. You have to look at its details very carefully. Alright, so in this case, we can say that we have two terms that is being multiplied, and that is x squared and the sine x. And each of these term has an x squared and the sine x. Alright, so we can say that here we can use the product rule. So product rule is discussed in our previous video. So if you want to review for that, you can just watch on my previous video. So the formula for the product rule is this one. So say that our u there is our x squared, and our v there is our sine x. Alright, so the product rule is just you have to take the u and you multiply it by the differentiation of the v, plus you have to take the v multiplied by the differentiation of the u. So our solution there will be dy over dx is equals to the v and du over dx from the formula, that is sine x and the differentiation of the x squared, where our v there is the sine x and the u is x squared. So we take the differentiation of the u, and that is the differentiation of x squared, plus that u and dv over dx from the formula is actually equals to that one, x squared and the differentiation of the sine x, where our u there is the x squared and the differentiation of v is the differentiation of our sine x. Alright, so that is how we solve our problem. So if we simplify this, we can have 2x sine x. Alright, so because if when we derive the x squared, that is 2x multiplied by the sine x, plus when we take the differentiation of sine, we can have cos, so we can have x squared cos x. Alright, so that is just how we solve our problems, and that is our answer. So in solving the trigonometric problems, you just have to understand and to study the previous formulas as well as the identities of the trigonometric function. So I will be showing you another example where we will have to use the trigonometric identities. So So on our second problem, we have y is equals to sine x all over 1 plus cos x. So previously we multiplied, so we used the product rule. So in this case, we are dividing, so we will be using the quotient rule, all right? And the formula for the quotient rule is just this one, where our numerator is u and our denominator is v, all right? So the solution for this is just y prime, or the dy over dx, is just equals to cos x times the 1 plus cos x minus sine x multiplied by negative sine x all over the v squared, which is 1 plus cos x squared. Alright, so you just have to follow what is written in the formula. So our v there is 1 plus cos x, and the d over dx there is the differentiation of sine, which is the cos x. That is where we get this part. And then minus our u there is just the numerator, so we have sine x, and the differentiation of 1 plus cos x is just a negative sine x, because differentiating 1 is 0 and differentiating cos is just the negative sine x. That is where we get the negative sine x all over the v squared, and that is 1 plus cos x squared. Alright, so in simplifying this answer, we can get cos x plus cos squared x plus sine squared x all over 1 plus cos x squared. So we know that in our Pythagorean identities for the trigonometric function, we have sine squared x plus cos squared x, that is equals to 1. So if that is equals to 1, we can say that y prime is equals to 1 plus cos x all over 1 plus cos x squared. And we have the same numerator and denominator. It's just that our denominator is raised to the power of 2. So therefore, we can simplify that as 1 all over 1 plus cos x. Alright, so 1 all over 1 plus cos x there is our answer. So in this problem, we use the Pythagorean identities in simplifying our answer. So Pythagorean theorem is really important. You can use it in simplifying the problem. It's either in the solution where you already substituted it in the formulas and then you are simplifying it, just like what we did here. You can also use that before simplifying. So if you think that equation can be simplified using the Pythagorean identities, then go ahead. You simplified it first before you derive. That's okay. No big deal for that. The answer will be the same. Alright? So you can use the Pythagorean identities before deriving or simplifying the answer. Alright? So let's move on our third examples. In our third example, we have y is equals to cos x minus 1/3 cos x cubed. So in this equation, we can see that there is a minus sign here, and that means that we will be using a difference rule for that. So we will be taking the derivative of each term separately, all right? And also, we can see that there is an exponent here, that is 3. So for that, we will be using the power rule, okay? So in our solution, we have y prime, or the dy over dx, is equals to that one, where the differentiation of our cos x is this one, and the differentiation of our 1/3 cos x cubed is this one. So that means we are differentiating it separately, and that is being separated by the minus sign. So how did we get 1/3 times 3 cos squared x multiplied by negative sine x? We just take the power rule for that. So for that, our exponent there is 3. So if we just multiply the 3 into our 1/3, and then we subtract it by 1, so that becomes 2. And then the base of our exponent is cos x, so we take the differentiation of that, which is the sine x, which is the negative sine x. That is why we have a negative sine x here, alright? So we just multiplied the exponent 3 to 1/3, so that is why we have this one. And then our exponent is being subtracted by 1, so we have 2 there. And then if we take the differentiation of the base of our exponent, which is the cos x, that is negative sine x, so that is this part here. So now if we simplify that, we can get negative sine x plus cos squared x sine x. Alright? So if we simplify that again, we can have negative sine x multiplied by 1 minus cos squared x. Alright? So distributive property where we take out the negative sine x. So our 1 minus cos squared x can be derived from our Pythagorean theorem, which is sine squared x plus cos squared x is equals to 1. So if we have 1 minus cos squared x, that means that is equals to sine squared x. Alright? So we can have negative sine x multiplied by sine squared x is equals to negative sine cube x. Alright, so that is just how we solve the problem. Okay, again, this is from the Pythagorean theorem where we have 1 is equals to cos squared x plus sine, oh, I'm very sorry for my writing, sine squared x. Alright, so this is cos. So if we transpose this there, then we can have 1 minus cos squared x, and that is equals to sine squared x, and that is where we get this part here. Okay, so negative sine x multiplied by sine squared x, so that becomes negative sine x cubed. All right, so that's negative sine x cubed is our answer. All right, so let's move on our fourth problem. So our fourth problem is y is equals to the natural logarithm of the square root of 1 minus sine x over 1 plus sine x. So there is a natural logarithm involved in this problem. So we will be using a natural logarithm rule that fit for this problem, and that is the differentiation of ln of u, where that square root of 1 minus sine x over 1 plus sine x there will be our u. Okay, so if we differentiate ln of u, we will have du over dx all over u. But other people are actually confused of that, how it is formed. So I would just make it this way. All right, so 1 over u multiplied by du over dx, that is just the same. I just make it clearer for you. Okay, so that du over dx there can also be written as the u prime, okay, or the square root of 1 minus sine x over 1 plus sine x prime. That is the differentiation of that equation. Okay, so in our solution we will have 1 over u, so we will have 1 over that square root of 1 minus sine x over 1 plus sine x, and then we will have to multiply it by d over dx, and that is the differentiation of that. So in order for us to get the answer, we would have to differentiate it first. Okay, so in solving that, we want to make it appear as if like it's just simple to solve, it's just easy to solve. All right, so because a lot of people, whenever they saw a square root sign in the problem, it makes them feel that the problem is difficult and they try to skip that one. Oh, it has a square root, I don't want to solve it, it's really difficult. You just have to make it this way. You know what, the equivalent exponent for the square root is just a 1/2. So we can have a base that is 1 minus sine x over 1 plus sine x, and our exponent for that is 1/2. All right, and by looking at that, we can say that we can use a power rule where we just have to multiply the exponent to our base, and we subtract that exponent by 1, and we get the differentiation of our base. Okay, so if you don't know how to use the power rule, you just go back into my differentiation for algebraic equations so that you will learn and how to use that rule. Okay, so for this, we would just have to make it this way. So as I have said, the exponent is 1/2. So if we multiply that to our base, we will have 1/2 multiplied by 1 minus sine x over 1 plus sine x. And then our exponent there is 1/2. So if we subtract it by 1, we will have a negative 1/2. And then we will multiply that to the differentiation of the base say that our base is m, so we will have dm over dx. Okay, so we will have to get the differentiation of that 1 minus sine x over 1 plus sine x there. So right now we still don't get the complete answer because we still have to differentiate that equation inside of that. Okay, say that dm over dx there. So if we differentiate that, we can rewrite that as 1 minus sine x over 1 plus sine x prime. Okay, so now if we try to differentiate 1 minus sine x over 1 plus sine x, we can use the quotient rule because there is a numerator, there is a denominator, and obviously we are dividing here, so we can just use a quotient rule in that. So by that, you know that our differentiation, the differentiation for u over v is just v du over dx minus u dv over dx over v squared. Okay, so if you don't know how to use the quotient rule again, you just go back into my algebraic differentiation and you will get the answer on how to use that. Okay, so in this case, we say that our numerator is 1 minus sine x, and that will be our u. So the differentiation of that is just a negative cos x. Okay, so the differentiation of sine is cos, and we will bring that negative or the minus sign there. Okay, and then say our v there is 1 plus sine x, and the differentiation of sine is just the cos again, so we would have cos x there as our dv over dx, and then we just have to substitute that to our formula like that, and we will get negative 2 cos x over 1 plus sine x squared. So therefore, if we have our du, the value of our du over dx is just equals to 1/2 multiplied by 1 minus sine x over 1 plus sine x raised to the power of negative 1/2 multiplied to that value, which is negative 2 cos x over 1 plus sine x squared. Okay, so now we get the exact value of our differentiation for the u, or the square root of 1 minus sine x over 1 plus sine x. Okay, so the correct answer, the complete answer, looks like this. Before I show you how it looks like, I just wanted to summarize how we solve our problem. So we started solving this problem by using the differentiation of ln of u, and we get, in our solution, we get this. Okay, so in that solution, we still have to get the differentiation of this. So in our answer, we already have this part, so we can take that as a part of our answer, but our answer is not complete yet because we have to differentiate that equation there in a red box. Okay, so we differentiate that using our power rule, and we get this one. Okay, so in this case, we still have to differentiate this part. So we can take this out again as part of our answer, and we still have to differentiate that another red box there, which is 1 minus sine x over 1 plus sine x prime, and there we use the quotient rule. Okay, that's the formula for the quotient rule, and we get in our solution this one. Okay, so we can take that again as part of our answer, so therefore our complete answer for that is this one. Okay, so that is how our answer looks like. But to tell you guys, this is not simplified. So we have to simplify it first. We have to get its lowest term, or we have to simplify that to make it, or to make the equation shorter. So we have to simplify that first. So simplifying our answer, we can get 1 plus sine x over 2 multiplied by 1 minus sine x, and that will be multiplied with negative 2 cos x over 1 plus sine x squared. Alright, so that one, if we simplify that again, we can just cancel the 2, and then we can just cancel this, and this will become 1. So we can have cos x over 1 plus sine x, and another one for the 1 plus sine x. Okay, so simplifying that, we can simply say that it is negative cos x over 1 plus sine squared x. Alright, and simply that 1 minus sine squared x there is just the cos squared x, So we can say that it is negative 1 over cos x. So therefore, 1 over cos, that is secant, so we can have as negative sec x as our answer. So can you just imagine that we started using that very long answer and we get this when we started simplifying. So, you know, whenever you get the answer, you still have to simplify that, because sometimes our answer is very long, but the answer is actually very short. Okay, so that is why you have to simplify. So our last problem there is y is equals to 1 minus 3x, and that will be raised to the power of cos x. Okay, so you know the base has an x and the exponent has an x. So this is simply relatable to the exponential function, all right? So that if you still remember, in the differentiation of an exponential function, we have this as our formula, okay, where our base has an x and our exponent has an x. Okay, so in this problem, we can say that 1 minus 3x is our u, okay? And our exponent, which is cos x, will be our v, okay? So if we differentiate that, we can have du over dx, that is negative 3, and then our exponent, which is cos x, so if we differentiate that, we can have negative sine x. Okay, now that we have a u, v, du over dx, and dv over dx, we just simply you know, follow what is written in the formula, so we can have this one as our solution. Okay, so if we simplify that, we can have this as our answer. So that will be our answer. Okay, so you know, in every time you solve a problem, you just always have to remember those formulas that I gave you, from the algebraic function to the exponential and logarithm, and also this part for the trigonometric functions, that one, as well as the identities of the trigonometric functions. Okay, so you know that those are the important formulas whenever we are solving the differentiation of the trigonometric functions. So don't forget to subscribe and learn a lot from my tutorial, and also tell your friends to visit on my channel and share my videos. Okay, thank you so much. God bless.
Subscribe!
Subscribe.
Subscribe! 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 Subscribe!
Subscribe.
Please like and share. Subscribe.